When we did the Blinky Car lab, we drew a special kind of graph that's called a position versus time graph. On these graphs, we put time on the bottom axis, so I'm going to use a letter T, and we put position on the side axis. In physics, position is actually abbreviated with the letter X. So I know it seems strange to see an X on the y-axis, but get used to it. We're going to be doing this all year. Each point on a position graph shows you where the object was located at a specific time. And it's all compared to what we call the reference point or the 0 point. Now, there are some patterns that you need to be aware of when you're drawing and interpreting position graphs, because these patterns make it a lot easier to answer questions. First off, if you have a very steep graph, that means that the object was moving fast. Notice, the position is changing a lot, even though the time axis hasn't moved forward very far. So you're making a lot of position in very little time. That means you must be going fast. If you're not as steep, this means you're going slow. Notice your position didn't change by very much, and it took you a lot of time to get there. So, very little position, a lot of time. That means you're going slow. If your position graph is flat, this means that you are not moving. Notice your position stays the same at all times. In other words, you're not going anywhere. Okay? So you need to be able to see these patterns quickly. Steep is fast, flat is not moving. Another possibility is that your graph is going downhill. Downhill just means that you're going backwards. In other words, you started far away and you're coming back towards the 0 point, okay? You're getting closer to the start line. The last thing you need to know about position graphs, if you start on 0, that means that you started at the origin or where we expected. It is possible, however, to start further up the axis. If your graph starts up high, that just means that the object got some kind of a head start. It didn't start at the reference, it started somewhere else. So by moving up the axis, we can see how big of a head start it was given. So let's look at a couple examples. You need to be able to both draw these graphs and interpret them on your own. So let's say that we have this. Okay, notice whatever this object is, it's moving forward. I know this because the graph is going uphill. It never comes down, it never comes back to the beginning. At the beginning, this object was going slow. I know that because it's not very steep. Then we have an interval here in the middle where it stopped. The object wasn't moving. Maybe it broke. And then, oh my goodness, look how steep this is. Suddenly, my object is going fast, fast, fast. So if I was trying to give this story a context, I would say that my car started off on the race going pretty slow, and then it blew a tire, and it had to stop and fix the tire, and then it was scared that it was going to lose the race, so it took off as fast as it could to try and catch up to the other cars. Every position graph, even though it's just lines, really is telling a story, and you need to be able to see what that story is.